channel. Hello, all parts of the world. Okay, welcome to my white world. This is again, I am a singer, eternal voice, Sotero. Okay, again, let's go back to redox, reduction, and oxidation. Okay, so these reactions are very essential in chemistry, okay, general chemistry, and also a prerequisite in your stoichiometry subjects in your higher chemistry, okay, because it will be needing in the balancing of equations also, okay, like that. Oh my god. But this time I'm gonna discuss about redox in basic solution. And after this, I'll be able also to discuss redox in acidic solution in my next vlog. But this time, basic solution. Okay, let's have a quick review what is a reduction is. A reduction is a process of gaining of electrons, receiving of electrons. So meaning, if you gain electrons, meaning to say the oxidation number and the oxidation state of particular atom, element, or whatever has been decreased or decreased. So we denote that as arrow down, okay, later during the determination of the reduction and oxidation in our chemical reactions later, okay? So that is reduction. For oxidation, that is a loss of electrons, meaning giving off the electrons to other atoms, molecules, something like that. Okay, it's gonna be like the transfer of electrons in various pieces. That is redox equations. This shortcut method for reduction and oxidation processes. Okay, something like that. And then if oxidation, so it's gonna be the increase in oxidation state or oxidation number. Okay, like that. Because somewhere along the way we will be confused sometimes, okay, as I'll show you later, we will be confused, but just try to consider more on the oxidation state and the oxidation number, sorry. Okay, when there is an increase in oxidation number, meaning that is a loss of electrons. When there is a decrease in oxidation number, that is a gain of electrons. Okay, when an atom, molecule, or a substance or an ion gain an electrons, okay, it is reduced. So the substance are being reduced or an element is being reduced. So if undergoing a reduction, it is being reduced also. Okay, and then for oxidation, it will be oxidized. The oxidation, undergoing a process of oxidation, oxidized. Undergoing a process of reduction, reduced. Okay, now if it is reduced, so that is a oxidizing agent. Now if it is oxidized, that is a reducing agent. If that is reduced, that is an oxidizing agent, something like that. Okay, so that's why it's very confusing, right? Okay, but anyway, we can really understand from time to time, okay? Because even now I am still confused. Oh my gosh. Okay, now I have an example here. Zinc, redox equations to zinc plus nitrate, okay, nitrate is equals to zinc 2 plus NO2. Okay, in this redox, okay, we need to be alerted by the charges, okay, because it deals with the charges when we determine the oxidation state and the oxidation number. Especially in determining the oxidation and reduction process, we need to know the oxidation number and the oxidation state changes. Okay, something like that. So arrow down for the oxidation number decreased, arrow up for oxidation number increased. Okay, now, so let's go to the individual charges or oxidations. For zinc, meaning it is a solo element, so that is 0. Okay, so this is a nitrate, right? Okay, nitrate. So we denote that as like this, NO3. Okay, so let's get the individual charge of oxygen and nitrogen. For oxygen, we have -2 oxidation state of oxygen, oxidation number of oxygen. Oxidation number of nitrogen is X because we don't know yet. Oxidation number of nitrogen is X because we don't know yet. The oxidation number of oxygen is -2. Okay? So, since the charge is -1 outside this close and open parentheses, so we need to say that one. So, X times 1 plus -2 times 3 is equals to -1. X times 1 meaning X times 1 subscript X times 1 plus -2 times 3 is equals to -1. Okay, so here it is. X times 1 is X. -6 is equals to -1. X is equals to -1 transposed -6. X is equals to 5. So this one, simple algebra. So X is equals to 5, our charge, and with the nitrogen, to the nitrogen, and we will substitute this 5 to the nitrogen here. Okay. Okay. We put that here already. 5 for the nitrogen from here. Okay. Now for the zinc, okay, that is 0. Oh, no, 2, sorry. 2. So +2. The charge is +2, huh? 2 plus is the valence, it's not the charge. The charge is the +2 for zinc, sorry. Okay. And then for the NO2, this is the NO2. Close and open parenthesis NO2. This is a compound. So this has no charge. This is neutral. That is nitrite. Nitrite, close and open parenthesis, is a neutral. So no numbers here. That means neutral or 0. So that is 0. So individual oxidation number is, so -2 for oxygen. And let X again the oxidation number of nitrogen. So X, okay, plus -2 times 2 is equals to 0. X is equals to -4 is equals to 0. X is equals to 4. So X is equals to 4 here. Okay, for the nitrite through linear equation like this. Okay. Okay. X times 1. X times 1 plus -2 times 2 is equals to 0 because 0 there is literal charge. Then X plus 4 is no X -4 is equal to 0 transpose X equals to 4. Put the 4 in nitrogen, and the oxygen also is -2. Now these are all the charges: 0, +5, -2, +2, -2, and +4. Take note, those who are undergoing changes of the oxidation numbers or the oxidation states undergoing oxidation and reduction. Take note, oxygen -2 charge here initially, and after that -2 also, so there's no change in charges, so we should not consider this one. Consider only the zinc from 0 to 2 and nitrogen from 1 to 4. Now our oxidation from the definition is the loss of electrons, meaning there's an increase of oxidation number. So this is gonna be our oxidation. Zinc is our oxidation. Okay, from here to this is oxidation. Okay, arrow up, oxidation number increase, and then zinc is oxidized. Okay, from here there is an increase in oxidation number from 0 to 2, so arrow up. Okay, this one arrow up, oxidation number increase. Okay, now this undergoing the loss of electrons or the oxidation, then zinc has been oxidized, therefore zinc also is a reducing agent. Okay, like that. So this is our from zinc to zinc positive 2, and our reduction will be, take note here, will be the from positive 5 to positive 4. So there's a decrease of oxidation number, so this is a gain of electrons. This one here, nitrogen, like this, nitrogen. So this is the reduction. So this is NO3 negative 2 NO2. So oxidation, no, sorry, reduction. So there's a decrease in oxidation number, so nitrogen is reduced. Okay, like that. So take note the nitrogen. So the nitrogen undergoing the process of reduction because there's a gain of electrons, and then there's a decrease of oxidation number denoted as down. ON means oxidation number, arrow down, decrease oxidation number. So that is the gain of electrons. So the process is reduction. So the nitrogen is being reduced, and therefore our nitrogen is the oxidizing agent. Okay, we will remember this, equations of the oxidation and equation of the reduction later. So this is the first step in the redox in basic solution, determining the oxidation and reduction process. Okay, second step, we need to have the half reaction. Okay, half reaction. Oh my gosh, half reaction, sorry. Half reaction for the oxidation. So we have oxidation, Zn to positive, half reaction, then balance the number of atoms. So zinc is equals to 1 and zinc is equals to 1, like this for the oxidation. This number of atoms, we did not balance the charge yet. So zinc is equals to 1 atom and zinc is also 1 atom. Okay, and now for the reduction. So we have here, we will get, this is our reduction. We will just transfer this equation. This is our reduction to balance the number of atoms. Okay. NO3 negative, NO2. Nitrogen is 1, nitrogen is 1, oxygen is 3, oxygen is 2. So in the reduction from nitrate to nitrite, so nitrogen is 1 here, nitrogen is 1 here, oxygen is 3 here, oxygen is 2. So in role of balanced chemical reaction, we need to go to the insufficient number of atoms to balance the oxygen. Okay, we let the number of X of atoms supposedly. But here, in every insufficient oxygen, we need to add water to balance the oxygen. Okay, so we need one more oxygen to balance the three oxygen here. So plus one H2O in this side here. So plus H2O plus H2O, or simply one H2O. So balance again. So oxygen now will become 3. So oxygen now is balanced. Okay, oxygen 3 upon adding one water there. And then we introduce another element with it, which is H. So we need to balance again. So to balance the H is to add also an H plus to balance the hydrogen. Okay, so since we have the H here, we put that here. H is equals to 2 here. Equals to 2, H equals to 2. And the other side, there's no H here, right? So we need to balance that one. We need to put 2H to balance this H here. So 2H. So hydrogen 2. So your balancing of hydrogen upon adding here will be depends on water. After balancing this water, so you need still H on the other side also. That's why we need to put 2H. Okay, so 2H plus nitrate equals to NO2 plus H2O, and then balance the number of atoms. Okay, 2. Finally, nitrogen 1, oxygen 3, and hydrogen 2, hydrogen 2. So this is now balanced. Okay, reduction. Procedure number 2. After balancing the number of atoms in the half reactions of oxidation and reduction, we need also to balance the charges in the half reaction and the oxidation and reduction. We start for oxidation. So balance the charges. It's not atoms already, but charges. So zinc is equals to zinc 2 positive. Okay, like this. So zinc, this one is understood to be 0 because it is neutral. So 0. Okay, charges. And zinc is positive 2. Zinc is positive 2, and in the periodic table, we have the positive 2 charge of zinc. And then zinc is 0 in a neutral state. So balance it. Okay. So positive 2 plus X is equal to 0. So X is equals to negative 2. Okay, so 0 is equals to 2, X equals to negative 2, then positive 2 plus negative 2 is equals to 0. It's already balanced. Okay, 0. Zinc is 0, and then positive 2, so positive 2. Okay, like that. Okay, so since equals to 0, then X will be negative 2 to balance the 0 here. Okay, so we need to add negative 2. We have to add negative 2 to positive 2 to equal to 0. Positive 2 plus negative 2 is equal to 0, so we have to add negative 2. So this is negative 2. So this negative 2 will be our electrons. So like this, zinc is equals to zinc positive 2 positive plus 2 electrons. Okay, this is now our reaction. zinc is equals to, okay, this one, zinc 2 plus 2 electrons. Where did we get these 2 electrons? Here, okay, because this is 0 charge for zinc in a free state, and then positive 2 minus 2 is equal to 0, or we can have this equation. So understood, negative 2 is our charge for this. So since negative 2, so automatically negative 2 means 2 electrons. So zinc is equal to zinc positive 2 plus 2 electrons. Okay, like this. And then this is for the oxidation. For the reduction, okay, for the reduction, balance of the charges, we have 2H plus NO3, NO2 plus H2O. So 2, 0 plus negative 1, 0, 0. So 0, negative 1, 0. Okay, this is how to balance the charges. Okay, this is for the reduction. Okay, 2H plus nitrate is equals to nitrite plus H2O. So this is 2H. So this is 0 charge. Okay, 2 times 0, 2 times 0 plus nitrite is negative 1 here. So 1 times negative 1, that is negative 1. And then for NO2, there's no charge in the outside of this NO2, so that is 0. Okay, 1 times 0, 0. And here also H2O, that is 0 because it's a compound, 0. 0 plus 0, 0, negative 1. So we need to add positive 1 here to compensate equal the 0 here. So positive 1 plus positive 1, sorry. We need to add positive 1 here, okay? Positive 1. Okay, so that means in this means we need to add positive 1 here. We mean that as an electron. So we need to put here 1 electron here in this side, because this is the 1 electrons of this side, because this is the side where there is a deficient of number of electrons. Okay, so this is negative 1 here, 0 here, okay, here. So this negative 1 here plus 1 is equal to 0, like this. Okay, charges 0, negative 1. So negative 1 plus 1 is equal to 0. So plus 1 electron here, 1 electron here. Okay, so like this. The resulting equation will be like this. So reduction. One electron, or simply electron, plus 2H plus NO3 equals to NO2 plus H2O. This is now our balancing the charges or the electrons for the reduction. For the oxidation, we just copy the results here. The results here is transferred to another paper. Okay, oxidation is Zn 2 positive plus 2 electron. Now we need to add this all so that we can cancel out the same quantity. Okay, so as you can see, there is 2 electron, only 1 electron here. So we need to multiply this by 2 in algebra, so that it can equate to the 2 electron here, so that it will be cancelled both electrons. Okay, so like this, 2, so it will become 2 electrons, 4H plus 2 NO3 2NO2 plus 2H2O. This will not be copied. After multiplying this by 2 to compensate the equality here with these two electrons, then we can now have this equation here. Both sides are being multiplied by 2. All sides, all quantities. Okay? Now add the 2. So we have that. Okay? Zinc plus 2 electron negative plus 4H. Okay? Plus 2 NO3 negative. Okay, zinc 2 positive plus 2 electron plus 2 NO2 plus 2 water. Now if you add the two quantities here, so we have common 2 electrons and 2 electrons here, and we must cancel the 2 electrons, 2 electrons, 2 electrons, cancel that one. Okay, like that, like that. Okay, already cancelled. Okay, now in here we need to add OH both sides because this is balancing. The final step will be adding OH in both sides because it is redox in basic equation. So plus OH here and plus OH there also. Okay, so this will be equal to zinc plus 4H plus OH plus 2NO3 negative, zinc 2 plus 2NO2 plus 2 water, okay, plus OH, okay, like this, plus OH, like this. Okay, we need to add OH both. Okay, this basic solution. So OH here and OH here. Now find the common. There is water here. There's water here. So this is same as 4H2O, 4 moles of water. So 2 moles of water, there's a common. So this must be cancelled with 2 moles of water here and here also, both sides. So minus 2 moles of water equals to 0. Okay, since this is 4 water minus 2 moles of water, so this is equals to 2 moles of water. So here will be 4 moles of water, 4H2O minus 2 moles of water. Okay, because there's 2 moles of water here. So 2 moles of water here minus 2 moles of water is cancels out, 0. So here we still have 2 moles of water here. So zinc plus 2 moles of water plus 2NO3 is equals to zinc 2 plus 2NO2, okay, plus OH negative. This is our final redox equation here. Zinc plus H2O plus, okay, like this, plus 2 nitrate is equal to zinc 2 plus 2 moles of water plus OH. Now we need to balance the oxygen to make it confident that we are correct. Okay, this is the last portion. Okay, left side and right side. Wait, 5 minutes. Okay. So, balance by atoms first. Zinc is equals to 1, and zinc also is equals to 1. Hydrogen is equals to 4. Hydrogen is equals to 4. Okay, oxygen is equals to 2 plus 6 equals to 8. Oxygen is equals to 4, 8. So, by the way, if you add, you know, 4OH here, you also add 4OH on the other side, huh? Okay, like that. If you add OH both, like this, okay? So now, like that, okay? Balance. Zinc balance, hydrogen balance, and oxygen balance. Now for the charges, zinc, for the charges, zinc 0, 1, hydrogen 0, and this is negative 2. Okay, negative 2 charges in the left, total charges in negative 2, total charges in the right. So this one, okay, this is very crucial. Okay, uh, this is 0, this is negative 2, and positive negative 2 and negative 2. So negative 4, positive 2, so negative 2. So balance the charges in the left and right, and also the atoms balance in the left and right. Okay, so every time you add OH on the left, you also add OH on the right. Okay, something like that. Okay, so this has been balanced already. Okay, that is redox in basic solution. Thank you so much for watching this live streaming. And then if you don't subscribe yet, please subscribe, and then click the notification bell from some newest updates of MC Engr Eternal Force. Thank you so much. Bye bye. God bless everybody.